All right, welcome back for another deep dive. Today we're taking a look at YOLOv3,
Ah, yes, YOLOv3.
a computer vision system for object detection. And we're going to be going through the paper YOLOv3, an incremental improvement.
Yes.
So this is a pretty dense paper.
Yeah.
We've got a link in the show notes if you want to follow along at home. But we're going to try to distill it down to what a programmer would need to know about it without having a deep background in computer vision.
Right. And it's kind of a fun paper to read, too, because it's got this kind of casual, almost irreverent tone to it.
Yeah, it's a little different than a typical research paper.
Mm-hmm.
The authors of the paper actually wrote this paper partly because they needed to cite updates that they'd made to YOLO for another project and they hadn't formally published them yet. So that's how we got this paper.
Yeah. Gotta love that. Gotta love when that happens.
Yeah.
So YOLOv3, which stands for You Only Look Once, version 3, aims to do what the name suggests, detect objects and images with just one glance.
Right.
And it has to do it quickly and accurately.
Yeah, I mean, that's the tricky part, right? Like you think about self-driving cars, you think about all these areas of AI where speed is of the essence, like medical imaging and things like that. Like it's got to be quick and it's got to be right.
Exactly.
Okay.
And YOLO 3 is an improvement on the previous versions of YOLO. You've got YOLO and you've got YOLO 9000.
Right.
And this one kind of refines the process and boosts the performance even more.
Yeah. So how does it do that? What's kind of going on at a high level?
So at a high level, YOLO 3 uses a neural network called DarkNet53.
Oh,
And this neural network analyzes the image and identifies potential objects.
okay.
And it does this by predicting bounding boxes around objects.
So it's not just saying, hey, there's a thing. It's saying, hey, there's a thing, and here's where it is.
Exactly. It's
Yeah.
drawing a box around the object.
Okay.
And it goes a step further by assigning class labels to each bounding box. So it might say, this is a car, that's a person, this is a stop sign.
Right. Okay. So it's identifying the thing and putting a box around it.
Yeah,
But how does it know where to put the box?
that's a good question.
Okay.
So they use this concept called anchor boxes.
Okay.
And you can think of anchor boxes as predefined box shapes and sizes that are learned from analyzing a massive data set of images.
Yeah.
So essentially, the network is using these anchor boxes as a starting point, and then it refines them based on the specific object that it's analyzing.
Oh, okay. So it's not having to come up with the box dimensions every single time. It's got these kind of templates to work with.
Exactly.
Interesting. Okay.
Yeah, and through some math and some clever innovations, they are able to predict the location and size of these bounding boxes with pretty impressive accuracy.
Okay, so we've got the boxes, we've got the labels. What was really cool about this paper to me is this idea of multi-label classification.
Right.
What does that mean?
So, in real-world scenarios, objects can often belong to multiple categories.
Yeah.
A woman is both a woman and a person. So YOLOv3 recognizes this complexity and allows for objects to have multiple labels, unlike some systems that might force it to be one or the other.
Oh, wow. Okay.
So it's a bit more nuanced in that way.
Yeah, that makes sense. I mean, that's how we see the world, right?
Exactly.
It's not just one thing. It's usually multiple things.
Yeah, and they do this through a clever use of independent logistic classifiers for each class, rather than the typical softmax, which can be a bit limiting.
Okay, now we also see this new feature extractor called DarkNet53.
Yes!
I don't want to get too deep in the weeds, but what is a feature extractor at a high level?
So you can think of a feature extractor as like the neural network itself. It's like the brain of the system. It's what's actually analyzing the image.
Okay.
And DarkNet53 is this new architecture that they use that's based on the idea of residual networks, which is a popular architecture in deep learning that's known for its good performance.
Okay, so it's basically a more efficient, smarter neural network driving this whole process. Gotcha.
Mm.
And they're claiming that it's both faster and more accurate than some of the other well-established alternatives.
Right. They specifically compare it to ResNet 101 and show that it actually outperforms it in both speed and accuracy, which is pretty remarkable.
Yeah, that's a pretty big claim, especially with ResNet being so popular.
Yeah.
All right, so what kind of results are we talking about here?
So one of the most striking aspects is the speed. YOLOv3 is often 3 times faster than comparable models.
Wow, okay.
So you can imagine this is really important for those real-time applications where every millisecond counts.
Yeah, right. Like self-driving cars can't be waiting around for the system to figure out if there's a pedestrian in the road or not.
Right.
Okay.
Now, in terms of accuracy, it's not necessarily the absolute top performer on every single metric out there, but it excels at what's called the AP50 metric.
Okay, what does that mean?
So AP50 basically measures how well the system draws boxes that accurately cover at least 50% of the object.
Okay.
So it's not just about drawing any box, it's about drawing a box that's a good fit.
Right. So it's not just saying, hey, there's a person somewhere in this area. It's saying, hey, I can actually outline this person pretty accurately.
Exactly. And at this specific metric, YOLOv3 performs really well. In fact, the authors even point out that even humans struggle to differentiate between slight differences in bounding box accuracy.
That's interesting. So if even our own perception has limitations, maybe those tiny variations in performance aren't that important.
That's right. It kind of puts things into perspective.
Yeah.
And it highlights that some of these metrics that we use to evaluate these systems might not be perfect representations of real-world performance.
Yeah, I thought it was really interesting that the authors dedicated a whole section to things that didn't work
Right.
in their research process.
It's kind of refreshing to see that because, it's not always sunshine and roses.
Yeah, they tried all these different things. Like they tried to predict the bounding box offsets in different ways. They tried different activation functions. They experimented with something called focal loss, and none of those things really panned out. But it's cool that they included that in the paper because it shows, the thought process and the challenges of developing a system like this.
Exactly. It kind of demystifies the process a bit
Right.
and shows that, even the best researchers don't always get it right on the first try.
For sure. So we've kind of covered the basics of YOLOv3, what its goal is, how it works at a high level, some of the key innovations. But there's a lot more to this paper.
Definitely.
And we're going to get into some of those other aspects in the next part of our deep dive.
Sounds good.
Welcome back to our deep dive on YOLOv3. So one of the things that I thought was really interesting about YOLOv3 is how it handles objects of different sizes.
Right.
So you could have a tiny little ant in an image, or you could have like a giant truck.
Yeah.
How does it handle finding both of those things?
So this is where the concept of a feature pyramid network comes in.
Okay.
And you can think of this as like analyzing the image at multiple levels of detail. It's almost like zooming in and out of the image.
Right. So instead of looking at the whole picture, it's breaking it down into different scales.
Exactly.
Yeah.
And by looking at both coarse features and fine-grained features, it can detect objects that range in size from very small to very large.
That makes sense because if you're only looking at like the big picture view, you might miss those tiny little details.
Oh, right.
But if you zoom in too much, you might not see the big picture.
Exactly.
So it's kind of finding a balance there.
Yeah, it's all about finding the right balance.
So, I mean, the authors are making this claim that YOLO3 is often 3 times faster than other models.
Right.
And you combine that with this multi-scale analysis, like it sounds like this is a really powerful system for real-time applications.
Absolutely.
Like video analysis,
Yeah.
self-driving systems, all that stuff.
Yeah.
Where it needs to be fast and it needs to be accurate.
Exactly.
Now, one of the things that I found particularly interesting towards the end of the paper is they almost dismissed the very idea of bounding boxes. They say that, bounding boxes are stupid, which is kind of a funny thing to say in a research paper.
Right.
And they hint at this idea that masks might be the future of object detection.
Yeah. It's a pretty bold statement.
Yeah. So let's unpack that a little bit. What are they talking about there? Like, why are bounding boxes stupid and what's so great about masks?
Well, a bounding box is just a rectangle.
Right.
It's just giving you a rough estimate of where the object is, but it doesn't really capture the true shape of the object.
It's like an approximation.
Right, exactly.
Wow.
So a mask, on the other hand, is a pixel-by-pixel outline of the object.
Oh, okay.
So it's not just a box around the object. It's a detailed representation of its exact shape.
So it's the difference between saying, hey, I know roughly where this thing is, and saying, hey, I know exactly where the boundaries of this thing are.
Exactly.
Okay.
And by having that more detailed representation, you can do a lot more with it.
What kind of things could you do with it?
Well, think about like medical imaging, being able to precisely segment a tumor from healthy tissue.
Right.
Or in robotics, where a robot needs to grasp an object with a very specific grip.
Uh-huh.
That requires a very precise understanding of the object's shape.
Right. Like if it was just a bounding box, it might just grab like the corner of the thing or something.
Exactly.
Yeah.
Yeah. So there are a lot of potential applications for masks.
So if masks are so advantageous, why aren't they the standard already?
Well, the main reason is computational cost. Masks require a lot more processing power than bounding boxes.
Ah, okay.
And in real-time applications where speed is really important, that extra processing can be a bottleneck.
So it's kind of a trade-off there.
Right. It's a trade-off between precision and speed.
You get more detailed information with masks, but it comes at the cost of processing time.
Exactly.
But as technology continues to improve and processing power gets cheaper and more accessible, do you think we'll see a shift towards masks?
I think so. I think the authors of this paper are definitely looking ahead and kind of anticipating that that's going to be the future of object detection.
And that's something that's interesting about this paper is they made their code publicly available.
Yeah.
So for our listeners out there who are programmers, could someone without a computer vision background actually download this code and start experimenting with it?
Absolutely.
Really?
Yeah, that's one of the exciting things about this paper is that the code is out there, ready to be used and explored.
That's cool.
And even if you're not an expert in computer vision, you can still dive in and start playing around with YOLO3 and start building your own applications.
That's really cool. It kind of democratizes access to this technology.
Exactly.
Now, we've talked about the technical side of things, but there's also the broader societal impact of a technology like this. So in the next part of our deep dive, we're going to get into some of the ethical considerations and the potential consequences of YOLOv3. All right, welcome back to the final part of our deep dive into YOLOv3. So we've talked about all the cool technical stuff,
Right.
how it works, the innovations, but now I kind of want to step back and look at the bigger picture. Like, what are the implications of a technology like this?
Yeah, I mean, this is something that the authors actually touch on in the paper.
Oh,
They acknowledge that, computer vision, especially when it's this advanced, it comes with certain responsibilities.
yeah, like it's one thing to be able to identify objects and images,
Yeah.
but like what happens when you can do that in real time on a massive scale?
Right. It kind of raises some ethical questions.
Yeah.
It's like any powerful technology, whether it's fire or nuclear energy,
Right.
there's a lot of good that can be done with it, but there's also potential for misuse.
So for our listeners out there who are programmers, what do they need to think about when they're considering using a technology like YOLOv3?
Well, I think it's about being mindful of the broader context. It's not just about building a cool application. It's about thinking about how that application could be used in the real world.
So like if you're building a security system with YOLOv3, are you also thinking about the privacy implications?
Exactly.
Things like that.
Yeah.
Yeah,
How do you ensure that it's used responsibly?
right. And it seems like we need those kind of ethical frameworks in place now before this technology gets even more powerful.
Absolutely. We need to be proactive.
Yeah.
And it's not just about the technology itself. It's about the people who are developing it and using it.
It's kind of a joint responsibility
Right.
between the tech community and society as a whole.
Exactly.
So what would you say is the biggest takeaway from this paper? For someone who's, maybe not a computer vision expert, but they're interested in this technology.
Well, I think the main thing is that YOLOv3 is a very powerful tool.
Yeah.
And with that power comes a lot of responsibility.
So it's not just about, like, the cool factor.
Right.
It's also about thinking about the consequences.
Yeah, thinking about the ethical implications.
Well, this has been a really fascinating conversation.
Yeah.
I learned a lot about YOLOv3.
Me too.
I encourage our listeners to check out the paper if they're interested in diving deeper.
Definitely.
It's a really well-written paper, and the authors have done a great job of making a complex topic pretty accessible.
Yeah, they make it fun to read too.
Yeah. And that's not something you can say about a lot of research papers.
Not at all.
So thanks for joining us on this deep dive into YOLOv3. We'll see you next time.